Yeah, so
Yeah.
thanks. It's good to be here. And I'm going to talk about a couple of different topics. First, just a little bit of high-level context on sort of what I do at Facebook and how we rank the feed. But then I thought it'd be interesting to talk a little bit about some of the just evaluation challenges that we have as we're thinking about any of these kinds of questions that Matt and John were sort of posing, and how even when after you can kind of align on some of the sticky policy or metric definitions, then just evaluating changes that we might make to make progress on some of these issues is actually quite challenging in the network. So let me start out here and just sort of set a little bit of context on how we rank newsfeed. And the primary goal, and this is what I've worked on at Facebook for a long time, is how do we provide people with the best experience and show them the content that they most want to see, right? So the goal, of course, is we want to help people to not miss the things that are most important to them, whether that's from their friends and family, or it's from the pages or creators that they follow, or the groups that they're members of. And we have to sort of figure out how to rank that heterogeneous set of content, and kind of a big part of the challenge is defining what is important to people and really understanding their preferences. And then once we do that, you put the best content at the top, and so when you come to Facebook, you're most likely to see the things that are higher up in newsfeed, and it's a kind of classic ranking problem, similar in many ways to what lots of other companies sort of face. And so I suppose one thing that's a little bit different from, say, like search, which is maybe the other big ranking problem that you would think of sort of first, is Facebook. There's no query to a certain extent. The query is you. You're coming and you want to see the best content that has happened sort of since the last time you visit. So our goal is to try and take all of the available content since your sort of previous visit to Facebook and assign some score to it, and then put the best things at the top. And this sort of evolves so that when you come back, then new things have happened, and there's new available inventory that then gets ranked and put at the top and pushes the previous things down and so on. So I think in some ways it's similar to a lot of other ranking problems, but it does have this sort of a slightly unique characteristic in that it is this sort of an infinite feed that is sort of ever changing, and where people have kind of an expectation that if they scroll back far enough, they'll get to where they were before. And so it's slightly different, and you're sort of always ranking new things and putting them at the top. And so the ordering is not always sort of exactly the same as the scores would suggest. Then if you came back only a few minutes later, maybe there's only one piece of content and doesn't have a very high score, not very interesting, but the model is sort of new things come in at the top, and that's one of the kind of like core product sort of principles. It has this nice sort of property where if you come often enough, it's sort of chronological. If you don't come very often, right, if you're only a very occasional user, then you would really get the best content from whatever the time period is that you were gone. And then in between, it sort of nicely interpolates. So that's a super high level. And then, of course, the devil is in the details of how do these scores get assigned. And figure that out. You can think about an example. That here's a piece of content that might show up in my newsfeed. This is from a friend of mine, posting a text post. It has some number of likes, some number of comments, and we have to figure out, to the best of our ability, how interesting is that to me, sort of how relevant is that, and compared to everything else. And so, of course, there's some like large-scale machine learning under the hood that's sort of trying to take in as many factors as we can in order to produce this final score. But some of the kind of, and I won't be able to get into like all the details in sort of the few minutes I have, but at a super high level, we're trying to express the major parts of this in terms of the things that we can sort of address with somewhat classic old machine learning techniques. So, whenever I'm presented with a piece of content, there's a number of ways that I can interact with it. And so that gives us a large corpus of label training data that we can then go and sort of use the state-of-the-art machine learning techniques in order to build the best prediction models that we can. Beyond just those sort of like engagement signals, though, the other thing that we've been trying to do is really align newsfeed not just with the things that you click the most or that you click the like button the most on, but actually align them with what is it that you would say you wanted, right? And so we have a number of programs where we go out to survey people to get their sort of stated preference. And so then the kind of like challenge is, how do you merge those sort of stated preferences, which have their own sort of biases in them, with the sort of revealed preferences that you get from people's interaction with all of the content in order to come up with a final score. And then you have to do the sort of dot product where there's a lot of different types of events, both the sort of like engagement ones as well as the sort of survey-based ones. You have to give them all some value. And I'm glossing over a bunch of the details. It's not quite as simple as just like predict a bunch of events and take a dot product. One of the kind of like key ways that we think about some of the sort of integrity problems and things like that is, how can we change the labels in these problems? And so there's sort of notions of like comments that are sort of not policy compliant, like those shouldn't count as positive examples into our training system. And then also, there is content policies that are beyond sort of your preferences. So there might be content that, if you were to go and ask a specific person, like, would you want to see this? They would say yes, but it is not doesn't align with Facebook's policies. And so we have to sort of layer in those additional things beyond trying to just optimize for people's preferences. And so, like I said, this is kind of a large scale machine learning system that tries to take in many different factors. But the key ones still are these sort of social signals. And so a big part of Facebook, I think we'll talk a lot about sort of like news and sort of like misinformation and content moderation and things like that in this panel. But still, the majority of content is actually sort of like people posting personal moments and things like that. And so a big part of what happens on Facebook is us trying to understand who are the people that you really care about, who are your close friends, which of your friends post the most interesting links that you engage with on a regular basis, things like that. And then, of course, what this leads to is a sort of personalized experience where a piece of content, like in this example, is going to be scored very differently for different people. And so these three sort of caricature figures, they're all considering the same piece of content, but end up with very different scores based on, I guess, like, their interest in the weather, how close friends they are with Wei, like a number of other factors that lead to the sort of personalized experience that everybody has. So that's the super high level of how newsfeed works. But then I think what was sort of interesting thinking about this specific panel is some of the challenges of how we evaluate changes within newsfeed and maybe within Facebook more generally, where the kind of like traditional A/B testing approach is, I have some new innovation, whether it's a ranking change or it's a product change, and I run a test on 1% of Facebook's user base, and I see a whole slew of metrics and the various ways in which they moved, and sort of run the test for long enough that those things converge and get some sort of readout of some metrics are up, some metrics are down, and then make some assessment as to whether or not it's a good change. And I think that works super well in many contexts. And you think about anything that is mostly like the inventory is static, or it's not sort of like the other side of the sort of marketplace is relatively static. That gives you an almost perfect sort of evaluation as to whether or not this is a positive change. On Facebook, though, everything is happening on a network, and so if I have a change that I'm only testing on 1% of people, well, only 1% of those people's friends are going to be exposed to that change as well. And so now any sort of change that relies on interactions between people, well, it'll only impact 1% of my interactions. And so I'm really missing a huge amount of the value. You can imagine sort of extreme examples of if you were launching a new messaging service, right? Only 1% of your friends are able to get messages. Obviously wouldn't capture the full value of whatever it was that you were doing. And so a kind of an illustrative example of this that I thought was sort of fun is we launched this feature last year called avatars, which essentially allows you to create your sort of a caricature version of you and use that within the product in a variety of ways. And I guess like many features, as we were developing this, once we got to a point where something we were sort of proud of, we started testing it in some smaller markets at a low percentage, and we wanted to see how people used it, like where did they get stuck in the creation flow, like collect some user feedback, all the types of things that you would do as you're launching a product. And so we had some data suggesting that this was going to be a sort of moderate success, that people would find the entry points to create their avatars. They would then make it through the flow and end up with something that they're happy with. And one of the kind of key metrics was the sort of post-creation survey, is like, are you happy with the way your avatar looks? The key thing that was that the A/B testing didn't really account for the virality of this feature. And when we launched it, we had the option for you to share your avatar to newsfeed, and the key sort of killer feature, I guess, which is like relatively obvious in hindsight and kind of seemed minor at the time, was that you had this try it button. And so now, if the feature is available for and people are seeing the try it button, it never has the opportunity to really go viral. But once you launch it to everybody, you sort of see that it like took off in a big way. This is sort of a significant ongoing challenge that we face, is how do we think about sort of evaluating any type of change, and this is just one of many examples. But I think that some of the things we've talked about, or we'll talk about in the panel, of information spreading is sort of another obvious case of how do you evaluate a change that impacts information spreading when it's very difficult to evaluate things on the full network. So in the case of avatars, due to virality, this actually was like dramatically more successful than we expected. The graph here, the sort of blue dashed line, shows the viral coefficient over time, and you can see that in the first few days it was greater than 1. And I guess we're all sort of armchair epidemiologists at this point, and so it was explosive viral exponential growth. It leading to the point where actually like some of the infrastructure started to fall over, and we had to sort of scramble over the weekend and wake people up in order to like find more hardware in order to support the feature. Which is sort of the fun champagne problem to have, I guess, is when your product launch is successful enough that you have to scramble to find more hardware. So a few different ways of approaching this. Because interactions are so core to Facebook, we've sort of developed different techniques, and they have different trade-offs. One approach is one that John and I worked on a long time ago, is the sort of idea of network bucket testing. You can also run tests in specific countries, or you can try and partition the entire social graph and sort of run tests on some of those partitions. Or another method that is a little bit easier to sort of evaluate but less perfect is these sort of heuristic approximations. And I'll run through each of these really quickly. So the first method that we have is sort of this network bucket testing approach that John and I worked on a while ago now, where can you find lots of sort of small clusters, so like the A's and B's in this diagram, and then those clusters are relatively well connected internally, and have a relatively small number of friends, sort of like the union of friends who are adjacent to those people. And then you expose some fraction of these random clusters, or I guess like half the random clusters and all of their friends, and then you can get a readout. It has some nice pros. There's no assumptions about the graph. It would work on social networks. It would work on kind of any graphs. It's a little bit complicated to set up. I think you also have to expose a lot of people on a social graph, given that the average person on Facebook has hundreds of friends. So if you're going to expose a person and all of their friends, you have to expose a lot. And it doesn't really capture the network effects that travel more than one hop, right? And so I think for all these reasons, it was, I think, like an interesting theoretical model to sort of kick things off, but it's not one that we've actually sort of used in practice. Another really simple thing is you just run tests in countries. And countries are great in that they're relatively sort of like high degree of endogeneity, and that most of the friendships that happen would stick within countries, sort of like as you might expect. And this diagram from a paper we did a few years ago shows sort of the adjacency graph between countries, and you can see along the diagonal everything is all lit up, and that sort of indicates what a large fraction of edges stay with countries. Now, of course, the big con here is like there's not that many countries, and so you can only run so many tests at once. Also, the variance ends up being kind of high, especially if one of the countries that you pick to test has some like large world event that is going to skew things in a big way. So I think that makes this a little bit challenging for all but the sort of most high impact experiments. The one other big advantage I suppose this has is it kind of captures the like conversation at the bar effect, although I use a different phrase for that these days, where presumably some of the network effects are happening off of the social network, and it's sort of people talking outside of the sort of online world, and those effects are probably very well captured by country tests and maybe not so well captured by things that only rely on the social graph. The third approach is you can do some sort of large-scale graph partitioning. This is one that we've used to kind of good effect within Facebook, where you can run some partitioning algorithm, you develop a bunch of clusters of the social graph, and then sort of similar to the network bucket testing approach, but I guess like rather than trying to expose a set of users and all of their friends, you just try to find the sort of most cohesive clusters and then randomly pick a bunch of them. This actually works quite well. The big downside is it's still like a bit complicated, kind of high overhead. You need to maintain this mapping from like all users to what cluster they're in. The clustering algorithm itself is sort of expensive, and so if you were going to run it multiple times for multiple experiments, that all kind of adds up. And the final approach, and this is actually the one that we use the most often, sort of like day to day, is this sort of heuristic approximation, where this doesn't work for something that is going to kind of push you outside of the realm of small changes, but for something that's sort of a small change and is similar to past small changes, you can go and try to, through a variety of means, estimate like what is the relationship between metric X and metric Y, where if metric X goes up by 1%, then metric Y will go up by 0.1% or some amount. And so you can kind of compute that matrix, and then you can take the sum of the infinite series, which is really just inverting a matrix, to compute this sort of like full matrix of what should we expect if we increase, think about all the relationships, like increase one metric, what's the kind of cascading effect. This works quite well actually for a lot of sort of smaller scale changes. And as long as you're kind of like working within the domain that you've previously worked, and you're kind of like heuristic, then your kind of like estimates of those initial entries into the first matrix sort of stay roughly correct. Then this is sort of like a good operationally simple way to do things. It of course doesn't work very well if you're pushing into domains where you're changing things in a way where the like initial matrix is sort of incorrect because the relationships between metrics are changed, or if you're doing some sort of like more dramatic change that is going to sort of just like push you well outside the domain, even if it's sort of like the same type of change, it's just larger than your kind of local approximation, like first derivative, would be correct in. So those are 4 different approaches. I think they all have their own kind of pros and cons, and none of them are perfect. I think this is still like kind of an ongoing area of work that is really core both to some of the topics that we'll talk about in this panel, as well as all the other product changes that Facebook makes, where we need to try to evaluate what is the full impact of the changes that we're making, not just in the sort of 1% A/B test, but on a longitudinal basis after we launch them.